Okay, so in this video I'm going to show you how to use the math function in RS Logix 500 for PLC programming. So first of all, the command I'm going to show you is multiply command. So type MUL as the shortcut for multiply. So let's say you want to multiply any value to get in like different units, or maybe you want this value every time you get a value you want to be multiplied by a specific number. Then this function can be used. Let's say you're getting some value from a sensor in form of integer. Let's say n70/1 is the value you're getting. Maybe write down units, unit conversion you want to do over here. So source B is the value, whatever units you're converting. Maybe you're converting pounds to kilograms, so then whatever the unit, maybe you need to write it down. Finally, when you it gets multiplied, and the destination, you write down an integer, or you can write down maybe a bit file 0/2. It stores down in the 0th word and the second bit. So yeah, okay, click OK, and here is the value. Whatever value you read from the sensor, it gets multiplied by 0.45, and the final value you get is in this form, the integer, and you can use this integer to use the multiplied value. Okay, so I'm gonna delete this one. Now I'm gonna start with one more, that is EQU, equal. Basically equal is like if any source you're finding is like equal to some value. Let's say you're getting a value from a sensor as in form of integer n70/1, and we're here. If you wanna check if the value is equals 45 or no. Unit conversion, it comes up. This unit conversion comes up because last time I mentioned the unit conversion. So any number you put in and assign the text, it's gonna come up even when you delete the thing. Once you put it again, it's gonna come up. So over here, this command knows like the value it reads from the sensor, it compares with the source B, and if the values are equal, then maybe if there is an output over here, let's say being B3s, anything, whatever, the file output, then this output gets energized if the value read from the sensor is equal to source B over here. Let's say that was the equal command, EQU. Then basic math is just add function. Oh, sorry. So let's put add function over here. So basically what it does is, if you're getting in 7 values from any sensor, let's say this value, source B is like you wanna add values from another sensor, then it adds up the value, gets in the destination over here, and 7 0 maybe /3. So your destination adds up the, maybe if there are two materials mixing, material 1 plus material 2, you know what the whole thing is filled with this destination value, and you can use this destination value anywhere you want to energize any output, or you want to use it as an input or anything. So that was the add command. Then I'll start with more. Let's start with the limit command. Let's go lim. Okay, so what a limit does is just similar to the name, right? So low limit is, let's say I mention a value 45. High limit, I mention 100. Oh, not 1,000, 100. And for test is the one we're testing. Maybe if I get values from a sensor, let's say n70/4 is the integer I'm getting from the sensor, then, and this is the output I want to get energized if this value is between 45 and 100. test means the value is in between 45 and 100, and 7 column 0/4. So yeah, if the sensor read is between this one, I want this output to be energized. So basically you can use it to energize the output if the value is between the limits. So that's the use of the limits function. Okay, so let's start with one another function, that is GEQ. It means greater than or equal to. If you're getting values from any tank or any of the sensor, and if it's like greater than or equal to the value specified in the GEQ function, then it should energize the output. So basically it's just adding an output and GEQ. So GEQ means greater than or equal to. Let's say source N70/1 is the one you're receiving the values from the sensor, and let's say I type down value of 100. So if it means that this value it reads from the sensor in the form of integers should be equal or greater than 100, then this output, whatever it may be, trees something, output energize, so it energizes the output. So that's the basic use of the GEQ function. Okay. Next I'm going to show you is the sub function, subtract. It basically means subtract. So as you know in mathematics, it's just SUB, type down SUB. Source A, let's say you're getting this value from the sensor again. This you wanna get this value subtracted by like 10. The final destination you get the value, maybe you got the sensor reading to be 20 and you're subtracting 10, you get the final value to be 10. And you can use it, and this is in the form of maybe 5. So this destination integer you can use anywhere to energize any output or something like that. Okay, the subtract function is done. Let's cut it off. Next I'm gonna show you is the division function, that is div. So division function, let's say you want to divide the value, any value in like unit conversion. Let's say if I have like the values I'm getting is in pounds and I divide it by some value to get in kilograms. So this value, let's consider I'm getting N70/5 in the form of maybe pounds. So like converting it to kilograms is like dividing by any value. I don't know the exact conversion, but you can put the conversion value over here. And the destination file you get as N70/6, you get the destination. So you can find out the value, exact value, and use this destination anywhere you want. So next I'm gonna start with the square root function. Square root is basic in the math, you use square root function. So square root function is like source, any value you're getting from the sensor is in the form of integer. You have this value, you might get the square root out the value, then you can use sqr, and the value, where if we have some value like let's say 49, then it's gonna, the destination it's gonna be N70/7, it's gonna be 7, and the destination you can use it anywhere for energizing output or X as an input or something as you want. Okay, so that's the thing with sqr. Next I'm gonna start with leq is less than equal to. It was similar like the greater than equal to. If you have a source, let's say this is the source, and since 70/1 is the integer you're getting, and you want like it should be less than 100 or equal to 100, then the output gets energized. So basically it's a type of condition you're adding to the run. That's it. Okay, so next I'm gonna show you is how to convert the binary coded decimal to a normal decimal value. So the function you use for that is TOD. So any value you get from a source, let's say N7, you're already having it in the form of binary coded decimals as like 0/1, and you want the destination to be like N70/2. So basically what it does is converts the binary coded value into a decimal form. So if you want to use it in the program or ladders, the destination value you're getting is in decimal that you can use. But binary coded decimal, if it's not possible to read, then this function can help you convert, as you can see over here. Binary, there are some values in the integers over here. You can write down in binary, you can write down in decimal, octal, whatever you want. But if let's say you don't have conversion, then this TOD can be used, because it only reads the, let's say, the decimal values and not the binary coded decimals. Then this function can be used. Next I'm gonna show you is the FRD. That is the so type in FRD. FRD is basically like converting a binary coded decimal to integers. It does not give you a decimal value, it just gives you an integer, because for some of the sensors or some of the value readings, it is important that your unit should be in integers. So let's say if you're getting it some 0/1 from a sensor in the form of binary coded decimal, and you want to convert it into, let's say, the integer, then N70/8. This integer value, the destination you're getting, is in the form of an integer, so no decimal values. You can use this integer in any input you want by entering this value, N70/8 as the integer value. Okay, so next we're gonna start with the scale function. So let's delete the 40. Next we mentioned SCL. So this function can be used if, let's say, you're having an analog input, any analog input value, and you want this to be converted to a value that the PLC or the program can read. It's like basically if you have a valve open, you don't know how much is it open or no. It's like the sensor that is giving you the values does like 4 to 20 milliamps. Then for what value of current, like how much valve was closed, can be determined using this one. So basically you press N7 any value. Remember this, the source should be always in a Word file and not a bit file. You multiply maybe with a rate of 4000 or the value you need to specify over here that's been calculated before. Offset is like they add the error or settlement value is maybe, let's say, maybe 100, and you have the destination value, so the final value of the read that is possible for the PLC to read, it's in this form. Like the destination contains the value in that form, and this can be used for energizing the output. Let's say if the valve, it knows that the valve was open this much, it wants to open it further or maybe close it down, then this value can help us determine. We can put this value as an input in the next rung, and the other output says that, like, if you want to proceed closing the valve or opening